Hello everyone. Today we are going to do a lesson on solving equations. And these are equations with variables. We're going to see some examples of some one-step equations and some two-step equations. The first thing you need to know about solving equations is to isolate a variable, you must apply inverse operations. Now, that is a very fancy way of saying to get a number by itself, a variable by itself, you must apply opposite operations. Inverse means opposite. Now remember, a variable is an unknown number. In math, it's usually represented with a letter. So any problem that you have, as long as you apply the inverse, you will be able to solve for that variable. Now, I'm going to make an inverse table here. So my inverse operations. Okay. Inverse operations. If I have addition, I'm going to apply subtraction. If I have subtraction, I'm going to apply addition. If I have multiplication, I'm going to apply division. And if I have division, I'm going to apply multiplication. I'm always going to do the opposite operation. Here is our first example. So, for example, if I would like to solve for x, and I have x plus 4 is equal to 16. I can look this a bunch of ways, okay? I can say, all right, so a number plus 4 gives me 16. What number, if I start there and I add 4 to it, gives me 16? But the way I'm going to figure that out is I'm going to do the inverse operation. So since I have addition, I'm going to apply subtraction. So this is going to be just from our table that I made on the first slide. If I have addition, I'm going to apply subtraction. So to solve this problem, I always like to draw a little line here underneath the equal sign to keep my sides separate from each other. I'm going to take 4 away from 4 because I don't want this 4 over here with the x anymore. I want it to be gone. The opposite of positive 4 is minus 4. The opposite of add 4 is take away 4. If I do something on one side, I have to do it on the other side. So I'm going to subtract 4 there as well. So now my new problem is going to be, well, 4 take away 4, that's 0. So I'm going to write a big 0 right there because those are gone. I'm going to bring my x down, and it's going to say x, and that is going to be equal to 16 minus 4, which is 12. Then I always go back and check my work. So for my check, I'm going to replace x with 12. So now I have 12 plus 4, and that's going to equal 16. And then I check, does 12 plus 4 actually equal 16? Well, 12, 13, 14, 15, 16. It sure does. So as long as I get this side is equal to that side, it checks out, and I know that my answer is correct. So the answer to this problem is going to be x is equal to 12. Okay. Let's do another example here. If I have, for example, 3x equals 27. Okay. 3. So I'm saying 3 times some number is going to equal 27. Well, I come over here and I make my little chart and I say I have multiply. If I have multiply, that means I need to apply divide. I have multiplication, I need to apply division. So on my sides of my problem, I have 3 times x. I need that 3 to cancel out. Well, the way that we cancel out multiplication is division. So I'm going to divide both of these sides by 3. 3 divided by 3 gives me 1. So now I have 1x is equal to 27 divided by 3, which is 9. So x equals 9. Okay, I got to make sure I'm right. So I go down here and I do my check. Okay, instead of x, I'm replacing with 9. So now I have 3 times 9. And I want to see, does that indeed equal 27? Well, 3 times 9, yes, is 27. So I get 27 is equal to 27. So it checks out. So my answer is x equals 9. Now, let's do a division problem here. Let's say I have x divided by 5 is equal to 16. X divided by 5 is equal to 16. All right, so I make my little chart and I say, well, I'm starting with division and I need to multiply. Now, a fraction bar means divide. So anytime you see a fraction, that means division. So x divided by 5 is equal to 16. The best way to look at that is you say, okay, some number split into 5 is equal to 16. So what I want to do is I want to multiply by 5 over here. Because if I multiply by 5 on both sides, this is technically 5 over 1. So what I'm going to get here is I'm going to get 5x over 5. Well, 5 over 5 becomes 1. So I'm going to end up with x equals 16 times 5 is 80. So my answer should be x equals 80. Now remember, I got to check. So I come over here and I check. And I say, is 80 split into 5 equal to 16? So I go to my calculator, or I come over here real quick and do just a little long division. 5 fits into 8 one time. Take it away, I get a 3, bring down my 0. 5 fits into 30 6 times. 5 times 6 is 30. I end up with a remainder of 0. I'm good to go. So, yes, 80 divided by 5 is 16. 16 is equal to 16. It checks itself out, so I know I'm correct. Okay, so next thing we're going to do is talk about two-step equations. Now, two-step equations just means you're going to have 2 operations instead of 1. Okay, two-step equations. So, for example, let's say I have 3x minus 1 is equal to 11. All right, so I have 3 times a number, and I'm taking 1 away from that, and it's equaling 11. Okay, so here's the first thing. Always, always, always start away from the variable. Always start away from the variable. So I don't want to worry about this 3 right now. First thing I need to get rid of is this -1. -1 and -1 are the same thing. So I want to get rid of that -1. So what I have and what I need to apply are actually 2 different things now. I have subtraction and I also have multiplication. So what I'm going to need to do is I'm going to need to add and I'm going to need to divide. So here If I had subtract 1, I'm going to want to add 1 here. Well, remember, whatever you do to one side, you must do to the other side. So I'm going to add 1 there. Negative 1 plus 1 is 0. Remember, negative and minus mean the same thing. So now I have 3x on that side. Bring down my equal sign. 3x is equal to, well, 11 plus 1 is 12. Okay, so I've done that inverse operation. So now I need to do this inverse operation. If I have multiply, I need to divide. So I need to divide by 3. 3 divided by 3 is 1. X is equal to 12 divided by 3. Oh, I forgot my line here. 12 divided by 3, which is 4. So my answer, if I'm correct, should be x equals 4. So I come over here to my check. And I'm going to rewrite this problem. Instead of x, I'm going to have a 4. So I have 3 times 4 minus 1 equals 11. Okay, now I work order of operations. Multiply comes before subtraction. So I'm going to multiply 3 times 4. I'm going to get 12. Bring down my negative 1 and equals 11. 12 minus 1 is in fact 11. So it checks out and I'm correct. I'm going to do one more of these. It's going to be a tough one. It's going to have some division in it, and division looks a little crazy sometimes. So let's say I have x divided by 4 plus 5 is equal to let's say 10. So x divided by 4 plus 5 equals 10. So I come over here and I make my chart. Okay, I have two operations here. I have addition, and remember I always start away from the variable, and I have division. So I'm going to need to apply subtraction and multiplication. So first thing I'm going to do is subtract 5 here. So if I subtract 5 there and I subtract 5 there, okay, 5 minus 5, 0. Bring down my x divided by 4. So I have x divided by 4 equals 10 minus 5, which is 5. All right, so I've done this. So now I need to do my multiplication. I'm going to multiply both sides by 4. Remember, that's technically 4 over 1. And then I'm going to multiply by 4 over here. 4 and 4 are going to cancel each other out into a 1. And so I'm going to have 1x is equal to 5 times 4, which is 20. So my answer should be 20. Now remember, we always must check. So for my check, I'm going to replace my x with 20, and I'm going to say, okay, is 20 over 4 plus 5 equal to 10? Okay, well, 20 divided by 4 is 5, and 5 plus 5 does in fact equal 10. So I'm going to end up with 10 equals 10, which means my answer checks out. Please like and subscribe if this video helped you. Leave a comment if you would have something you would like me to make a video about. And I hope you have a wonderful day.